Hey guys, welcome to video lesson 3.1. We are now in chapter 3. Congratulations, we've made it. Today our essential question is, how do rates help you describe real life problems? And if we take a look at the picture here to the right, we have two sets of snorkel rental prices. One is $8.75 per hour. And the second is $7.25 per hour. So we're going to take a look at the meaning of the word rate. When you rent snorkel gear at the beach, you should pay attention to the rental rate. What does that mean? It means how much you are paying per hour. So the rental rate is in dollars per hour. So let's get started. We have three vocabulary words that most of you should be familiar with at this point, and you can find them on page 100 if you notice in your math textbook. A ratio is a comparison of two quantities, so we're comparing 3 to 4. And let's take a look at a rate. A rate is a ratio of two quantities. Remember, ratio is just a fancy word for saying fractions. Quantity means, if you take a look at miles, that's one quantity, that's one label or one unit. And hours is another label or unit. So we're comparing miles to hours. So we go 60 miles in 2 hours. Or if we take a look at a recipe, 6 eggs to 3 cups of flour, and any other units that we can compare and put together. And finally, if we take a look at unit rate, it's where we figure out where a denominator is 1. For this example, if we went 60 miles in 2 hours, we would divide numerator and denominator by 2, so we get a denominator of 1, and then 60 divided 2 is 3. So this would be an example of a unit rate, because we know per hour we are traveling 30 miles. Okay, let's get started. We're going to take a look at some real-life problems that involved products. Product means multiplication of amounts and rates. So we're going to find each product and we're going to write the unit. So for this first example, we have 6 hours times $12 per hour. So what we can do in this case is cross-cancel hours. So it's 6 times 12. So we're going to divide out the hours, which we just did. We cross-canceled. 6 times 12 is 72, which means we have our answers, or answer in dollars. So for this next example, I can cross out months. So now I have 6 times $700, which is $4,200. Oh, that's not writing too well. Okay, boop. 4,200. Okay, for example C, which is over here to the right, we have 10 gallons times 22 miles per gallon. So I can cancel or cross-cancel gallons. So now I'm left with 10 times 22 miles, which gives me 220 miles. All right, letter D, I can cross-cancel pounds. And that leaves me with 9 times $3, or $27. And this last example, I have 13 minutes times 60 seconds per minute. That allows me to cross-cancel minutes, giving me 13 times 60. So 13 and 6, 8. I get 780 seconds. So please be sure these 4 examples are written in your notebook, and then you can move forward. All right, for these next examples here, we're going to find the ratios and the rates. So ratio means we're going to set up some fractions. And let's go back to our vocab. What's a rate? We're going to compare two quantities. So we're pretty much going to write 2 fractions. So find the ratio of males to females is question A. And then question B is we're going to find the speed of the subway car. So if we have 45 males and 60 females in a subway car, the subway car travels 2.5 miles in 5 minutes. So part A, what's the ratio of males to females? All right, that description is very, very important. We want to know males to females. So it must be written in that order, males to females. Okay, so we need to make sure we write 45 over 60. Congratulations, you just wrote a ratio. And we could also reduce the ratio because we can reduce fractions. So the ratio of males to females is 3 to 4. For question B, we want to know the speed of the subway car. Well, what does that mean? We want to know how fast it's going per minute. All right, I know it went 2.5 miles in 5 minutes, but we want to know how fast can it go in 1 minute. So we write 2.5 over 5 minutes to miles. Sorry, I got it backwards. Miles to minutes. So we're going to divide by 5 because I want that denominator to turn to 1. So 5 divide 5 is my denominator is 1, and 2.5 divide 5 is 0.5. If I haven't said so already, you are welcome to use a calculator through all of Chapter 3. So if you want to pause the video, go grab a calculator, or turn the calculator on your computer, please do so because all of our work will be done with a calculator for Chapter 3. So the speed is 0.5 mile per minute. That's how fast a train can go, 0.5 mile for every minute. Next example. This is finding a rate from a table. So the table shows the amount of money you can raise by walking for a charity. Find the unit rate. That's a very important word right here. Find your unit rate. That means how many dollars do I earn per mile? Okay, you see that? That's very, very important. So please be sure you make note of what we're doing here. So if I take a look at this table, I walked 2 miles, I earned $24. So that doubles. I went 4 miles, so I earned $48. That doubles, or 2 more miles, and that goes up another $24. So the pattern, I need to make sure I look for the pattern. Every time I increase my miles by 2, I increase by $24. So what we want to do is find the unit rate in dollars per hour, dollars per mile. So I'm going to find the unit rate, my dollars money, compared to my distance or miles. So every $24 I raise, I walk 2 miles. So what does that mean? It means the money I raise increases $24 every time you walk 2 miles. We can reduce this. Okay, we want to find unit rate. So unit rate means that the denominator needs to be 1. So I'm going to divide 24 and 2 by 1. So I get $12 over 1 mile, which simply means that I earn $12 for every mile you walk. Next example. The graph shows the distance that speed travels through water. Find the speed of sound in kilometers per second. Okay, so if I take a look at the graph, keep your eyes right here. 0, 1, 2, 3, 4 represents your time, seconds. So no seconds or 0 seconds, 1 second, 2 seconds, and so on. And if I take a look at the y-axis, the 0, 1, 2, 3, 4 up to 6 and so on represents distance in kilometers. So if I take a look at this point 2, 3, that means after 2 seconds I have traveled 3 kilometers. Or if I take a look at this point here, 4, 6, that means after 4 seconds I've traveled 6 kilometers. So it says here, find the speed of sound in kilometers per second. Right here, that's your instructions. So we're going to start by picking a point. So we're going to take a look at point 2, 3. The solution will work out the same in the end, and it doesn't matter which of the 2 points you pick, and I can show you both. So we're going to pick the point, distance traveled over time. Okay, so we're going to take a look at 3/2 kilometers to seconds, distance over time. So that means if you take your calculator and do 3 divided by 2, you're going to get 1.5. So that means I can travel 1.5 kilometers every second. Right, the graph shows the cost of buying tickets to a concert. I'm sorry, it is a little blurry. It's not your computer. So the bottom, the x-axis, shows us the number of tickets we are buying. And the y-axis shows us the cost in dollars. So when I take a look at this first coordinate, 261, that means 2 tickets cost me $61. So 4 tickets cost me $102. And 6 tickets cost me $183. So question A, what does 0.4122 cost? 4 tickets cost $122. What's the unit rate for question B? Question B is pretty much saying, what does it cost for 1 ticket? So $61 for 2 tickets. Okay, so I'm comparing dollars to tickets. So I'm going to take both of these numbers and divide them by 2 because I want my denominator to be 1. So take your calculator and do 61 divided by 2, and you should get 30.5. 30.5 or $30.50 per ticket. All right, now that I know question B, what's the unit rate, or how much does 1 ticket cost, I could answer question C. What does it cost, the cost of buying 10 tickets? Well, that's pretty easy at this point. If I know what 1 ticket cost, I can just take this number, $30.50, $30.50, and I can multiply it by 10. And if you know your rule for multiplying by 10, the decimal is just going to move to the right once. So it's going to cost me $305. Or you can use your calculator and do 30.50 times 10. You get $305. So $305 for 10 tickets. Okay? Are the 2 statements equivalent? Explain your reasoning. The ratio of boys to girls. Okay, remember, this is very, very important, is 2 to 3. So let's write this down. Oops. Boys, girls, 2 to 3. It's asking us if girls to boys, 3 to 2. It's asking us if these 2 are the same ratio. Are they equivalent? Okay, so are the statements equivalent? Yes or no, and explain why. All right, this is something I want you to write in your notebook, and we will discuss it in class. All right, the next example. A sports store sells 3 different packs of tennis balls. Which is the best buy? Now, what students do when they see this example, they look at the 3 costs and say $11.49, $16.79, or $22.99. And they say that this package here, the $11.49, is the best because it's the cheapest. But think about it. In this one example, in the $11.49, you're only getting 4 packages. Here, you're getting 6 packages or 6 tubes, and here you're getting 3, 6, you're getting 9 tubes. So you're getting 4 tubes, 6 tubes, 9 tubes. So what we need to do is find the unit rate for each of these. We have 3 problems that we need to solve. We need to take $11.49 over 4. We need to take $16.79 over 6. And then we need to take $22.99 over 9. So let's go to the beginning. $11.49 $2.49 divided by 4 is roughly $2.87 per one tube. Let's go to the 1679, divide that by 6, and that's roughly $2.80 per one tube. And if I take a look at the 22.99, that's roughly $2.55 per one tube. So if I take a look at the unit rates now, if I take a look at what it cost for one tube in each of these packets, now I have the same number of units in all three of my scenarios. Which one is the best deal? Which one's your best buy? And hopefully you are telling me this is your best buy, the package of 9, because each tube costs $2.55, where in the 6-pack you're paying $2.80 per tube, and in the 4-pack you're paying $2.87. So those are more expensive than this last tube here, or this last package. All right. Finally, a table shows the amount of money you can raise by dancing for a charity. Find your unit rate in dollars per hour. Remember, for every 6 hours, you raise $90. So if I go another 6 to 12 hours, I increase another 90. I increase another 6 hours to 18, I increase another $90. So the pattern up here is plus 6, and the pattern on the bottom is plus 90, and plus 90. So what you want to do is find the unit rate in dollars per hour. That's the important part here. So that's how I want to set it up. I want to set it up as dollars over hour. That's how I want to write my ratio. Remember, ratio means fraction. Okay, so every $90 that I earn, I walk 6 hours. So I will be dividing both numerator and denominator by 1. So use your calculator. 90 divided by 6. This means I earn $15 for each hour that you walk or dance. All right, so the question number 1 is how much money is raised if you walk 6 miles? Oh, I'm sorry, this is not hours. This is per 1 mile. So if I earn $15 for 1 mile, I can simply take $15 and multiply that by 6. And if you can't do that in your head, use your calculator. And that means you earn $90 for 6 miles. Okay, we're going to stop here. Remember, there have been some vocab words. Please be sure for tomorrow you answer the critical thinking question and also be able to explain to me the difference between rate and unit rate. And be sure you have this ready to discuss in class. And the vocab that you should have for this lesson is rate, unit rate or unit ratio, and the word ratio. Have all these ready for tomorrow's discussion. And some of you, if not all of you, should have these 3 words already defined from class the other day. All right, great work, guys. Be sure you complete your assessment and have your notes ready.